Hello dear students, this is Professor Bhumisha from the Computer Engineering Department, Silver Rock University. Today, in our video lecture, we are going to study about the subject Fundamentals of Programming 1, and the topic that we are going to cover is regarding the introduction. So let us begin. The very first thing that we should know when we are talking about the programming is regarding the computer system. Now, what is computer? The computer word is a synonym for a machine which is commonly operated for purpose that is of technological and educational research. That computer word actually comes from the word compute. That means we want to calculate something, right? So this computer is nothing but a machine which is obviously designed by the human for the main purpose of using in the field of technology and education as well as research. Then we talk about the computer. So back in the years, the computer was actually is nothing but the electronic device, which is basically used for performing the arithmetic operations, right? But with the high speed. As a human being, if you are about to perform any calculation at that time, obviously we are going to take some time. But when it is applied to the machine, that the same operations can be performed within the second of time. We can also process the data in form of different formats like pictures, sound, graphics and all. Nowadays, this computer system is used so vastly that every kind of computation can be done easily. We can say that it is a general purpose computer that is given the appropriate instructions and required time, and it should be able to perform the most common computing tasks. So basically with the help of computer, we can perform number of things with the less time, very quickly and obviously very accurately. Now how this computer system actually works. So for that we need to understand the block diagram of a computer system, how it is actually designed. So basically, as you can see in the figure, the block diagram of the computer system is consist of main four components. The very first component is nothing but the input. Second one is output. Third one is a control unit and the secondary memory. Now let us see how this all the blocks of the computer system works. So very first we should talk about the input section. Now what is input section? Now you can see that input section is having an arrow inside to the control unit, right? So all the data that we are receiving by the computer, it goes through the input section only. The input unit comprise of different devices. Devices like that we are using, like mouse is there, keyboard is there, scanner is there, that are nothing but the input devices. Using these devices, we are providing the information to the system. Then after, the system processes it and that data will be come out through the help of output section. The data that is to be processed is put through the input unit. The computer accepts this raw data in a binary form. Now, what is binary data? So we must know that the computer system do not understands the alphabets or numbers. It only understands 0 and 1, that is called the binary data, right? So whatever the data we are giving to the computer system, whether it is in any form, that will be converted into the binary data. Okay. So it converts the human understandable input to the computer controllable data. So computer controllable data, that means what? A binary data. Then after, CPU accepts the information from the user. Now over here you can see that the third statement says CPU accepts the information from the user through input devices. Obviously we need to give some instruction to the system. So that instruction will be given through the help of input devices. And for giving the input to the computer system, we may have the devices like mouse, keyboard, touch screen, joystick and etc. Joystick, I think you know that it is normally used for the gaming purpose. Now when we talk about the another portion of a computer system is nothing but the output section. Now what is output section? A section where the data is displayed. Okay, the devices that are used to send the information to the outside world. Like in input, what we are doing, we are getting the data to the system. Now, if we want to give the data outside the system, at that time the output devices are used. What it does, it simply converts the data stored in ones and zeros. Now, what is 1 and 0? As I told you, it is nothing but the binary data. It converts the data stored in the zeros and 1 in the computer to human understandable information. As a human, we are not easily recognize what is 1 and 0 combination. For that, we need to convert it into the higher level language, that is nothing but the human understandable language. Right? So that work is done by the output devices. What are the examples of output devices? Obviously, the monitor, printer, speaker, through where we are getting the data, where we are getting the visible output. That is called the output section. The third portion of the computer system is the CPU. It is also known as the brain of the computer system. Why it is called brain? Because we know that in our human body, brain is the main component which is analyzing the instruction, which is receiving the instruction, which thoughts about it, and then it performs the action. Similarly, in the computer system, we are providing the data with the input section, we are getting the data on the output section, but in between these two devices, what is to be done, that is taken care by the CPU. That is why it is known as the brain of the computer system. What it does, it is nothing but it is simply an electronic circuit for performing number of actions, right? And it is controlling the data into the system. Whatever the data we are providing through the input section, that is being taken care by the CPU. Depending on what kind of data, what task to be performed, this data is analyzed and controlled by the CPU. And then after getting all done, the output is given to the output section. Now when we talk about the CPU, it mainly contains the three components. One is ALU, one is CU, and another is main memory. Now what is ALU? It is nothing but, as you can see, it is arithmetic logical unit. Now the word itself describes the purpose of this ALU. Arithmetic operations like we are talking about addition, subtraction, division, multiplication, logical expression like comparison and all, that all things are being taken care by the ALU. Right? It takes the data from the memory unit and returns the data to the memory unit. Now what is that? So when we talk about the memory, the computer system mainly consists two memory. One is primary memory and second one is secondary memory. Primary memory is also known as the RAM, random access memory. Random access memory, that means it's kind of volatile. It will be there only at the time of execution. Once the execution is done, whatever data is consumed by that memory will be free. That is why it is known as a volatile memory. The second portion in the CPU is known as a control unit, CU. What it does? So as we have already seen the second point, it controls the flow of the data in the system. So this is taken care by the CU. It controls all other units in the computer system, right? The input section, the primary section, the output section, these all are being taken care by the compute control unit. And the last and important portion is primary memory. Primary memory is also known as the main memory. It is nothing but the RAM. In the computer system, you may have the heard word RAM and ROM. So that RAM, random access memory, is nothing but the primary memory. It is also known as a main memory. It processes the CPU, directly stores and receives the information from it. Whenever we are executing any particular instruction, at that time that particular data is stored in the main memory. The process is being taken care over there only. And then after, whatever the data is generated, whatever the data is calculated, that will be reflected on our output screen. Generally, currently executing programs and data are stored in the primary memory. Whenever the process is there, whenever the program is in execution, remember that data will be there in primary memory only. And the last portion that we are having is, the next portion in the computer system is the secondary memory. The secondary memory is also known as the external memory, auxiliary memory. Why it is external memory? Because it is directly not included in as a part of CPU. It is attached to the CPU. This is also known as the read-only memory, ROM, where the data resides. For example, hard disk is there, floppy disk, CD, DVD, pen drives that we are normally using. These are all having the secondary memory where our data is residing. This data will be there until we are erasing it, right? It is used to store the data permanently. As I told you in the previous part, the primary memory will be having the data till the time of execution. The data will not reside over there, but when we are talking about the secondary memory, if we want to store the data, for example, in your computer system, you are having the data in form of pictures, in form of songs, in form of movies, in form of educational study material. That data remains over there. So that particular location is nothing but the secondary memory. We are storing the data into the hard drive of the computer system. So whenever we are about to store the data permanently, at that time we are using the secondary memory. Now, another important terminology when we are dealing with the computer system is regarding the hardware and software. Many times you have gone through this word, what is hardware? So normally the definition that comes into our mind is the things that we can touch is referred to as a hardware, and the things that we cannot touch but we can use is referred to as a software. So yes, this is true. Hardware is nothing but a physical part of the computer system. For example, if I am talking about the CPU, yes, I can touch it, I can have it, this is nothing but a hardware. A keyboard, I use it. For example, mouse, again, this is nothing but the hardware. So hardware are the physical parts of the computer system. It is also referring the mechanical devices that make up the computer system. As computer system, when we talk about the computer system, the main things that are part of it is monitor, CPU, keyboard, mouse, etc. So obviously these are nothing but the mechanical parts. They all come together and make the computer system. So these all are known as a hardware. User can see and touch the hardware components. So that is nothing but the hardware. And when we talk about the software, so what is software? A software is nothing but kind of software application, a set of instructions. What is set of instruction? For example, if I want to perform any addition of two numbers, so what is the procedure? I need to take the numbers, two numbers, I need to make the addition, I need to store the data in some another variable, that is called the procedure, that is nothing but the instruction. So this set of instruction in some logical order for performing some meaningful task. Over here, what was my task? I want to perform the addition of two numbers. So that is my task that I want to perform, and for that what instruction I give? First of all, I need to read the two numbers. I need to perform the addition, that is my second task, and next I am getting the output and displaying it. So that set of instruction in a logical order for performing some meaningful task is known as a set of program, and that set of program is nothing but the software. See, when we talk about hardware, what I said, it is a mechanical device. A device cannot perform anything until we are giving the instruction. So when we are talking about computer system, it is nothing but the combination of software and hardware. Hardware is a device through which we are getting input, output, etc. But to make them perform, we need a instruction, and that instructions are nothing but the software. It tells the hardware how to perform the task. Now, when we talk about software, we need to know that how many types of softwares are there. The very first type is system software, and another one is a application software. These are the basic two types. Now, what is system software? Now, it is designed to operate the computer hardware efficiently. It provides and maintains a platform for running the application software. Say for example, Windows, Linux and Unix. These are nothing but the examples of what? Operating system. These operating systems are telling the hardware in which form they are supposed to perform the task. To make them run, what type of software is required? A system software. And what is application software? So say for example, it is designed for performing some specific tasks. For example, if I am saying about the Microsoft Word, so it is used to perform the task regarding writing, for making the document. When I'm talking about Excel, so it is designed to perform the storing the data. PowerPoint is used for representing the data in some meaningful graphical way. So these all type of softwares are having their specific applications. So this category comes into the application software part. So this is about the software. Now the types of computer languages. Now what is computer language? We know that it is a designed instructions for performing the task. But these are basically divided into the three categories. The machine level language, the assembly language, and the higher level language. Now as you can see in the figure, at the bottom part we are having the hardware. Hardware is what? A device through which we are either inputting the data or getting the data. Now directly with the hardware, which type of language is associated? A machine language. This machine language is nothing but the computer language, the language that computer understands. As I told you previously, a computer can understand only 0 and 1, a binary data, right? So machine level language is also known as a low level language. It is nothing but the language of binaries. A computer directly understands this language only. Now we as a human are not providing 0 and 1, right? So at that time what we are having? Above the machine language you can see the assembly language. What is assembly language? It is nothing but the mnemonic to represent each of the machine level language instruction. It requires a translator known as an assembler to convert assembly language into machine language so that it can be understood by the computer. So assembly language are dealing with the machine language. And now upper there we have the higher level languages. What is higher level language? A language that is understood by the human. It is machine independent language. That means, for example, for the higher level language we can see there is the example of Java, C++, Basic, C. These are the programming language which are written in the English like language. For example, in C program we are writing printf statement. So that printf is understood by the human, that yes, the purpose of this statement will be of printing something. So higher level languages are specifically designed for the humans, a programmer, which they can understand. Once we are writing the data in the higher level language, it is then converted into the machine level language which can be performed by the computer system. Then the data is generated and again at the output level we are getting it back in the higher level language. So these are the three types of computer language. Now, the three another main important portions are compiler, interpreter, and assembler. Now, what is compiler? So, as the definition says, it translates the program of higher level language to the machine language. It converts the whole program at a time. As in the previous figure, what we have seen, a machine level language is dealing with the hardware and human are dealing with the higher level language. So how that higher level language is converted into the machine level language? For that we have the two different softwares. One is compiler and one is interpreter. What is compiler? What it simply does, at a time the whole program is converted into the machine language. For example, when we talk about C, C is having the compiler. A program written in the C is first of all compiled. Then after the compiled data is converted into the machine language so that a machine can perform on it. It is converting into the 0 and 1. So at a time the whole program is converted into the machine language with the help of compiler. Interpreter is also doing the same thing. It is also converting the higher level language to the machine level language, but a line by line. For example, Python. In Python language, we are having the interpreter. What it simply does, it first checks the first line, it converts into the machine language. If it is okay, it is going to the second one and so on. While in the case of C, what happens? The whole program at a time is compiled into the machine level language. And the third is assembler. It translates the program of assembly language into the machine language. Assembly languages are converted into the machine language with the help of assembler. Now algorithm. What is algorithm? Again, when we talk about the programming, the main two components are directly designing or first of all make a code of it. First of all, make a steps for it. So for that, the very first step is algorithm. What is algorithm? A finite set of instruction, a finite sequence of well-defined steps for solving the problem. Like over in the figure, you can see there is an input. Then after that input is given to some set of rules to obtain the expected output from the given input. And once that all the set of instructions are performed, we are getting the output. So algorithm is nothing but set of instruction which can be written in any language. For example, I can write the same algorithm in English, in Gujarati, in Hindi or any language. It is not depending on the programming language. That algorithm later on can be converted into the programming language. For example, this is the algorithm to add the two numbers and print the result. So in the human understandable language, what we have written a common English statement. Say for example, the very first portion is what? A start. Then after I need three variables, number 1, number 2 and result. Then after what we are doing, we are simply reading the two numbers on which we want to perform the addition. So in the third step, what we have done, read the values for the number 1 and number 2. Next step, add that values and store the result into the res variable. And in the fifth step, what we are doing, we are simply printing the result. And once all thing is performed perfectly, we are stopping the program. So algorithm, as you can see, this is set of instruction for performing any particular task. Flowchart. Algorithm and flowchart are the initial steps before writing any program. Algorithm is nothing but set of instruction written in any particular language, while flowchart is doing the same thing but with the help of graphical representation. The instruction that we are writing in the algorithms are now represented with the help of graphical way. So flowchart is a graphical representation of algorithm. And obviously it is easy for us to understand with the help of flowchart. Programs often use it as a program planning tool to solve the problem. It makes the use of symbols that are connected among them to indicate the flow of information and processing. Like in the figure you can see the start is there in one symbol. Then after we have a specific symbol to get the input. Then after there is a diamond shape. That diamond shape indicates if we are supposed to check any particular condition. And if condition is getting true, we need to follow the left route. If it is false, we are going to the right route. And finally, we are ending the whole process. So algorithm is written statements while flowchart is a graphical representation. Now here is the difference between flowchart and algorithm. Flowchart is a pictorial or graphical representation of program as I explained earlier, while algorithm is finite sequence of well-defined steps for solving any particular problem. Flowchart can be drawn with the help of various symbols. The specific symbols are there for making the flowchart. They are predefined. We are supposed to use it. While algorithm can be written in any natural language like English. Flowchart are easy to understand while algorithm is difficult to understand. Why this statement is there? Because when we are talking about the small programs, it may have very less instruction like 5 to 7, it is easy for us to understand. But consider the code where it is having number of instruction above 50, say for example. So it will be quite difficult for us to understand. But if the same thing is represented with the help of flowchart, it will be easy. Flowchart is easy to show branching and looping. Branching and looping is the concept of any programming language where we are supposed to repeat any instruction, then looping will be there. When we are supposed to check the condition, go and follow any particular rule, at that time branching will be there. So flowchart, with the help of flowchart, the same concept is delivered easily. But with the help of algorithm, it will be complicated to represent the concept of branching and looping. But as we can see, flowchart is having more benefits over the algorithm, but the last statement is the reverse of it. Flowchart for big program is impractical. Say for example, a program which is having multiple conditions to be checked. At that time, showing the flowchart will not be easy, but yes, algorithm can be written. Whatever the complexity of program, whatever the line of code of the program is there, algorithm can be done. But drawing the same thing on a single page will not be easy with the help of flowchart. So that is why the last statement is saying that flowchart for the big problem is impractical and algorithm can be written for any kind of programs. These are the symbols that we are using in the flowchart. Starting and stopping can be shown with the help of this symbol. Process is used with the help of this square symbol. Input and output is shown with the help of this given symbol. Decision making, we are using the diamond symbol. Arrows left, right, top, bottom are used for showing the direction, and subroutines are shown with the help of this given symbol. Say this is the example of that algorithm that we have seen previously, addition of two numbers. So over here is the flow chart of the same thing. Over here the very first step is start, which is shown in the ellipse symbol. Then after, with the help of input symbol, we are getting number 1 and number 2. Then we are performing the addition of these two, and output and input, you can see they are representing in the same symbol. We are printing the sum, and then after the whole process is ending, right? So this is the graphical representation, or I can say the flow chart for any given two numbers. So this is all basic things about the programming language, the concept, what we have seen, like what is computer, a block diagram of computer, hardware, software, types of programming language, software, as well as algorithm and flowchart. So thank you everyone.